Welcome to the Future Tech Explorations channel. This is going to blow your mind. Zooming through the air, leaving traffic jams in the dust. Flying cars, once a fantasy, are becoming a reality. But how do you actually build a car that flies? It's not just about strapping wings onto a Toyota. It's about clever engineering and cutting-edge technology. For decades, inventors have tinkered with flying machines. We've seen prototypes and test flights, but nothing quite ready for the average Joe. But things are changing. Companies are investing big bucks in making flying cars safe, reliable, and affordable. This isn't just about fulfilling a childhood fantasy. Flying cars could revolutionize transportation. Imagine shorter commutes, quicker deliveries, and easier access to remote areas. It sounds like science fiction, but the future is closer than you think. Let's dive into the world of flying car engineering and see how this dream is taking flight. First things first, what gives these flying machines lift? Traditional car engines won't cut it. We need something powerful, efficient, and quiet enough for city skies. That's where electric motors and batteries come in. Electric power is leading the charge in flying car development. It's cleaner than gasoline, quieter, and offers instant torque for quick takeoffs. Think of it like a giant drone, but big enough to carry people. These electric motors power propellers that lift the car and propel it forward. But batteries are heavy, and we need enough juice for a decent flight. Companies are constantly improving battery technology, making them lighter, more powerful, and faster to charge. The goal is to have flying cars that can zip around for a good while before needing a recharge. We're not there yet, but progress is happening fast. We can't have flying cars plummeting from the sky, right? Safety is paramount, which means using the right materials. Think lightweight, yet incredibly strong. Carbon fiber, often used in race cars and airplanes, is a top contender. Carbon fiber is incredibly strong for its weight. It's also resistant to corrosion and fatigue, making it perfect for the stresses of flight. Other advanced materials like aluminum alloys and titanium are also being used to build various components. The goal is to find the perfect balance between strength, weight, and cost. These materials need to withstand the rigors of flight without breaking the bank. As technology advances, we can expect even lighter and stronger materials to take flight. Now imagine trying to pilot a flying car. It's not as simple as driving. That's where computers and automation come in. Flying cars are equipped with sophisticated flight control systems that do most of the heavy lifting, so to speak. These systems use sensors, GPS, and advanced algorithms to control the aircraft's stability, altitude, and navigation. Think of it like autopilot on an airplane, but even more advanced. The goal is to make flying cars as easy to operate as possible, even for those without pilot training. Of course, safety is paramount. These systems are designed with multiple redundancies and fail-safes. In the event of an emergency, the car can automatically land itself safely. It's all about making flying cars as safe and user-friendly as possible. Section 5. Safety first. Keeping our heads in the clouds. Let's face it, the idea of thousands of flying cars zipping around above our heads is a little nerve-wracking. Safety is arguably the biggest concern, and engineers are tackling it from every angle. First off, redundancy is key. Flying cars have multiple rotors or engines, so if one fails, the others can keep the vehicle airborne. They also have backup power systems and parachute systems for emergency landings. Then there's the issue of air traffic control. We need a system to manage all these flying vehicles and prevent collisions. Companies are working with aviation authorities to develop new air traffic control systems specifically for low-altitude airspace. It's a complex challenge, but essential for making flying cars a reality. Section 6. Traffic control. Navigating the skies. Imagine a sky filled with flying cars, all jostling for position. Chaos, right? That's why we need a robust air traffic control system for low-altitude airspace. Think of it like air traffic control for drones, but on a much larger scale. This new system would use sensors, GPS, and sophisticated algorithms to track the position and altitude of every flying car in the sky. It would then direct traffic flow, preventing collisions and ensuring smooth sailing, or should I say, flying. This system would be entirely automated, using artificial intelligence to make split-second decisions and keep the skies safe. It's a complex challenge, but one that's essential for making flying cars a practical mode of transportation. Section 7. Out of the garage, companies leading the charge. It's not just backyard tinkerers working on flying cars anymore. Big-name companies and startups are pouring resources into making this dream a reality. Let's meet some of the major players. There's Aeromobile, a Slovak company that's been developing flying cars for years. Their latest model, the Aeromobile 4.0, looks like something out of a sci-fi movie and can transform from a car to a plane in seconds. Then there's PAL V, a Dutch company that's created the Liberty, a sleek, three-wheeled flying car that resembles a gyrocopter. It's already certified for road use in Europe and is undergoing flight testing for certification. And let's not forget about the big players. Boeing, Airbus, and even Uber are all investing in urban air mobility solutions. These companies bring their vast resources and expertise to the table, accelerating the development of flying cars. Section 8. A day in the life commuting with flying cars. Imagine waking up, grabbing your coffee, and hopping into your flying car. Instead of battling traffic, you simply lift off and soar above the congested streets. Your commute time is cut in half, and you arrive at work relaxed and ready to go. Flying cars could revolutionize commuting, especially in densely populated areas. They could bypass gridlocked roads, reducing travel time and stress. Imagine the time and money saved by avoiding traffic jams and expensive parking fees. But it's not just about individual commutes. Flying cars could also transform public transportation. Imagine air taxis that whisk you across town in minutes or on-demand air shuttles that connect cities and suburbs. The possibilities are endless. Section 9. Beyond the commute, flying cars reshaping society. The impact of flying cars extends far beyond our daily commutes. They have the potential to reshape society in profound ways. Let's explore some of the broader implications. First off, flying cars could improve access to remote and underserved areas. They could provide a lifeline to communities with limited infrastructure, connecting them to essential services, healthcare, and economic opportunities. Flying cars could also revolutionize emergency response. Imagine ambulances that can fly over traffic jams, reaching patients in critical condition faster than ever before. Or search and rescue teams that can quickly access disaster zones, providing aid and assistance. The possibilities for saving lives are immense. Section 10. Challenges on the horizon, what could slow us down? While the future of flying cars looks bright, there are still challenges to overcome. These hurdles could slow down progress and determine how quickly this technology takes flight. One major hurdle is regulation. Governments worldwide need to establish clear rules and regulations for flying cars, addressing safety, airspace management, and licensing requirements. Striking the right balance between innovation and safety will be crucial. Another challenge is infrastructure. We need to develop a network of vertiports or landing pads for flying cars to take off and land. This requires significant investment and urban planning to integrate these facilities into existing infrastructure. Finally, there's the issue of public acceptance. People need to feel safe and comfortable with the idea of flying cars sharing the skies. Building trust in the technology and addressing concerns about noise, privacy, and safety will be essential for widespread adoption. Section 11. The future is up in the air. A look ahead. The development of flying cars is progressing rapidly, but it's still early days. It's unlikely that we'll see swarms of flying cars filling the skies overnight. However, the future looks promising. In the coming years, we can expect to see more test flights, pilot programs, and even limited commercial deployments of flying cars. As technology advances and regulations evolve, the cost of production will likely decrease, making flying cars more accessible to the masses. The dream of flying cars is no longer a far-fetched fantasy. It's a tangible reality that's rapidly approaching. While challenges remain, the ingenuity and determination of engineers and entrepreneurs give us reason to be optimistic. The future of transportation is up in the air, and it's looking exciting. If you enjoyed this video, don't forget to subscribe to my channel for more content like this. Give this video a thumbs up if you found it helpful or entertaining. Leave a comment below and let me know what you think or if you have any questions.